Morning, everybody. Online, can you hear me? Can you see the screen? Just making sure. Just checking.
Yes, sir.
Yes, sir.
All right. Good. So we are on this 2022 January paper. This was the first of the 2 mock exams that we did yesterday. Tomorrow, I'll be doing the second one in the class. And the pass mark is 85%. Nice 85%. That's what we want. Trying to get grades now that we actually want to get in the exam or higher. All right. Just want to say a good thing before we start, right? So we're in this class and we are preparing for the math exam. Right? I kind of want to say that I want you all to kind of take cue from how we prepare for the math exam. Right? We go very, very hard, we go very, very intense, we do a lot of work, we practice from past papers, we do the past paper questions, and we have to redo any question we get wrong. And if we discover a weakness, we have to work on it until we clear those weaknesses. What I'm trying to say to you is that that is the same approach you have to use for your other subjects, not just maths alone. So whatever subject it is, it's a similar kind of approach that you have to use. You can learn content, and know content, But if you don't add preparation to the knowledge that you have, then you can still do less than your best in an exam. But when you know the content and then you're also prepared, and you're prepared by practicing and doing mock exams and doing work under exam conditions, find out your mistakes, learn from your mistakes, correct your mistakes, learn from your weaknesses, strengthen those weaknesses. That's all a part of the process of preparing for the exam. What you don't want to do, you don't want to carry errors into the exam room. So the aim is to make all those errors before you get to the actual exam. That is what you want to do. All right? So sometimes you find that you learn the content in school, you do well in school. You get a test, you do well in it. You get assignments, you do well in it. But for some reason, the exam grade is not up there. The reason why the exam grade is not up there is because we lack preparation. Knowledge alone not good enough. Learning the stuff not good enough. You have to learn and then prepare. We must add preparation for the exam to the whole process. You understand me? And if you're not getting preparation from some other teacher and some other subject, because there are a lot of teachers who might just teach you the stuff and send you off on your own, just say, go and study for the exam now. And they don't help you to prepare like I do. And you can learn from this process that I have employed in terms of how you prepare. So what I've been doing since March, I've been preparing you for the exam. I remember when we stopped teaching from about March, and between March and now, we've been preparing, learning how to manage the time, learning the structure of the exam paper, getting familiar with the structure of the exam, learning the syllabus, learning the strengths, learning the weaknesses, and so on. So you're going into the exam room, you go into the exam room prepared for the exam. You know how to operate. You're going into an environment now where you'll be comfortable. It's not going to be a stressful environment because it's like you have done this thing over and over again. You have to prepare. Right? So if you're not getting preparation for your other subjects, guys, You need to employ the same kind of approach that we have used in the maths. A very high intense, high volume of work kind of approach, right? Where your aim is to reduce and eliminate all the mistakes that you would have made in the actual exam. You want to make them before the exam so that you don't make them in the exam. That's all a part of the preparation process. All right, so I'm just saying that because I know that a number of you actually doing other exams. Maybe I should have said this to you before, but that is what you want to do. You want to prepare for your exams. You won't just go in there and do that. All right, no further. So this paper now, 2022, this was COVID year, and it was the only exam that year that was a paper 2. They had scrapped the paper 2 that year for the June exam, and they only gave I close it. They only gave a paper 1 that year. And still, even though it was just a paper 1, the overall performance was no better. That's the funny thing about it, you know. When they give paper 1 only, people still fail. They find some way to make people feel the same way. And what they do sometimes, they go after the SBAs and they attack the SBAs and mark down a lot of the SBAs and so on. And they put higher rating on some of the questions on the paper 1, right? So like new questions might carry a higher weighting. Not all the questions on the papers carry the same weighting, you know, because it all depends on the set of the mark scheme. And there was a video that CSEC sent out last year to explain how they arrive at the grade. And not every question carry the same weight, right? They might have the same mark. So 2 questions might carry the same 2 marks, but those 2 marks might not carry the same weight in the final exam. You get me? So it all depends. So they have the ways of separating the men from the boys, and so they can give a multiple choice and get almost everything right and still, you know. So the only way to be sure is the multiple choice paper only to get everything right literally. Then they can't wait nothing because everything right. You get me? But then they can still go after the SB, and that's why I have to ensure that they do an excellent SB. They don't give them any reason to want to mark down the SB. All right, if they come to that, because the SB is like a backup plan for them, you know. So if something happens with the paper 1 or with the paper 2, they just okay, turn our attention to SB, and they give greater focus on SB, and sometimes they just look at it and mark it down and think. Right? So anyway, let's do this paper 2. All right, and a good bit of these questions should be familiar with you. There's nothing strange about it. All right, some of them would have actually done while we're learning the various topics as well. So I really expect some good grades on this paper. And next week, we expect good grades on the papers next week as well. All right, so let's go. First question is our normal calculator question. Use a calculator or otherwise to work this out. So I'm going to put it in the calculator as we normally do, which is a mixed number first. And that's 4 1/5. See if we can finish the paper relatively quickly today. And then a fraction, proper fraction, a third. And then that is subtracting a mixed number, which is 1 1/4. And we'll kind of look and make sure it's the same thing we wrote there. That's on the paper. Check everything. Looks like it. And as a fraction, this is 3/20. So this is supposed to work out to 3/20. So this is equal to 3/20. Easy as that. Next question, they want us to work this out again with the calculator. So make sure you clear the calculator, guys. Clear the calculator. So there's a fraction on the numerator there. They have 4.1 minus 1.25 squared. You're putting that over 0.005. Again, you make sure you type it the exact same way. That looks like it. And so this is 507.5. 3 marks. Then we go on to this question. It says a stadium currently has seating capacity for 15,400 seats. All right. It says calculate the number of people in the stadium when 75% of the seats are occupied. So that's simply 75% times the total seating of 15,400. That's what you're working out. If you don't have 75% on the calculator, you can put 75 over 100, or you can put 0.75 for 75%. All right, I have the percent on my calculator, so I'm going to use it. And this works out. If you look at my calculator now, I'm going to write 75%. I could have put 0.75 times a seating capacity of 15,400. And so 75% is 11,550 seats. Calculate the number of people. Number of people there with the 75% full is that. All right, that's the answer for that one. Nice and easy. Next question says, the stadium is to be renovated with a new seating capacity of this. So it is increasing from what? It is increasing from 15,400. It's going from 15,400 and it's going to that figure. That's a new total that's going to be there. So it's going to be an increase. It says, after the renovation, what will be the percentage increase in the number of seats? So the percentage increase is the increase divided by the original amount times 100, because it's an increase on the original amount. You want that as a percentage. So let's write it like this. It's going to be the increase, INC means increase, over the original amount, that's what RIG for original amount, times 100. That's what they calculated for the percentage increase. All right? That's how you calculate it. The increase over the original amount multiplied by 100. So what is the increase? The increase is simply the difference between these two numbers. You know, I don't have to actually work out that what the difference is. I can put the increase as 20,790 minus 15,400. That is going to be the increase over the original amount of 15,400. All right, there's an increase on the original amount. Multiply that by 100 to get as a percentage, and we can put the answer right here. I'm just going to put that in the calculator now. I don't have to work on the actual increase separately. I don't need to show it. If you show it, no problem. So I'm just want to make one calculation. So it's 20,790 minus 15,400. That represents the increase, and I'm dividing that by 15,400. And at a percentage, I'm going to multiply by 100. It's 35%. So therefore, we have a 35% increase. If you work it out a longer way, a different way, and get the same answer, no problem. So it's a 35% increase we have. And I like to set out the question a way where I just use the calculator one time to get my answer. All right, that is it. Moving right along. Not going to spend a lot of time. This one says, a neon light flashes 5 times every 10 seconds. So it's the flashes, the ratio of the flashes to the time is 5 times to 10 seconds. Show that the light flashes this number of times in one day. We can do this as a ratio, you know. We can say, okay, 5 times to 10 seconds. Then all I have to do now is build up this side until it reaches 1 day. By multiplying up until it reaches 1 day. And then I see what this side is. It's going to be this amount. Let's do it. Now, first thing I want to do is bring this 10 seconds to 60 seconds, because that is 1 hour. I'm going to count up to 60 seconds first, which is 1 minute, sorry. To get this 10 to become 60, I'm going to first multiply by 6. I'm going to step by step. First multiply by 6. When I multiply by 6, I multiply everything by 6. So there's 5 times now. 5 times 6 becomes 30 times to 60 seconds. And this 60 seconds is basically 1 minute. I can put this as really 1 minute. This 60 seconds is really 1 minute, right? I'm going to put 1 minute in bracket here. But then I know that 60 minutes make an hour. I'm going to go step by step. You know? So I need to multiply this again by 60. I'm going to step by step. So to get this to become 1 hour, I'm going to multiply by 60 again. Multiply by 60. Because I want this to become 60 minutes, which is 1 hour. So when I multiply this by 60, it's going to become 1,800 times. Should be times. So this becomes 60 minutes now. 60 minutes. I'm not going to bother to put the second. No, the 60 minutes is basically now just 1 hour. to get the day, I need the hour now to become 24. 24 hours make a day. So then I'm going to now multiply by 24. So now I'm going to multiply by 24 as I want my 24 hours to represent a day. 24 hours a day. So I'm going to multiply now by 24. So I'm going to multiply this by 24 first. Let's do it over here. That's supposed to give me the answer. So it's 1800 times 24. So you get this figure there. 4320 times 24 hours, sorry, 24 hours. And that 24 hours is 1 day. And therefore shown, see, that is it, shown. I've shown that that's the number of times in a day. Now, if you do it some other way, no problem. Just decide to do it like a ratio. I multiply it up gradually. Carry the 10 seconds to 60 seconds, which is a minute. Carry the minute to 60 minutes, which is an hour. And then carry the hour to a day by multiplying by 24. And so when you reach 24, that is it. All right? That is it. If you do it some other way and get the same answer, no problem. No problem. All right? So I've shown that in 1 day, it flashes 43,200 times. Done. Next question. All right, I don't need the calculator for this one. This one wants us to factorize this completely. Only two terms I see there. I say the minus in between them, so I'm thinking about the difference of 2 squared. But initially, I'm going to go for the highest common factor. So in these two terms right now, the highest common factor is just a h. Only a h is common in the two of them, h. So factorize out the h. H out of this leaves me with 5h. H out of this, the h gone outside, leaves me with negative 12g, minus 12g. And I look inside here, can't factorize any further, that is it. That's the answer. Simple as that. One mark for doing that. Next question, they want us to factorize this. Again, for this n value is prime, I can do it the shortcut way. If you want to do it the long way and get the same answer, no problem. But we have to practice doing it the shortcut way. I can always check it. Because this number is prime, I already know 2 of the values that's going to be in the bracket. Let me make the pen a little smaller. I already know that the factors of this 2x squared is 2x and x. Then I need factors of this 6 to go here and there. And I know that the far product and the near product must give me the middle term. All right? So we can try factors of 6. We can try the error now. If I try 1 and 6 here to begin with, it won't work because the far product is going to be 12x. This is just 1x. That won't work because 12x minus 1x is this. And I know that I want the difference. This minus tells me that it is the difference between the far product and the near product that must give me my middle term. So 1 and 6 won't work there. Suppose I switch them around and put it here. 6 and 1. Then the far product will be 2x, sorry. And the near product will be 6x. The difference between 2x and 6x is 4x. Again, that won't work. So I'm going to the next factors of 6, which is just 2 and 3. So if I put a 3 here and a 2 here, the far product is going to be 6x and the near product is going to be 2x. The difference between 6x and 2x is 4x. My middle term is just 1x. Actually, minus 1x. So these won't work either this way. So it must be the other way around. I deliberately went through all the stages to show you. So I need 2 here and the 3 here, factors of the 6. The far product now is 4x and the near product is 3x. The difference between 3x and 4x is 1x. Just no matter of where you put the negative sign. All right? Because remember, when the n value is negative, the 2 signs in the bracket will be different. One will be positive and one will be negative. This tells you that I give the larger product the negative sign. The far product is 4x, the near product is 3x. The far product is greater. Give it the minus sign, give the near product the positive sign. And those are the factors right there. You can test it if you want. Because the far product now is minus 4x and the near product is plus 3x. 3x minus 4 give me this minus x there. So you know that you factorize it good. All right? So those are the factors right there. Just don't need no pen to work when one of the numbers prime. If you want to go to the process and split the middle term and all of that, no problem. All right? But if you don't practice it the shortcut way, you won't learn to do the shortcut. You have to practice it the shortcut way as well. And it allows you to understand the factorization and expansion even better when you practice it the shortcut way. Right? Because the method that we use with the A times C and almost is almost like a road process. You don't really understand what is happening behind the scenes. When you learn to do it this way, you will appreciate and understand the quadratics and the factorization and so on. The values a lot better. All right? Let's continue. Next question. Next question wants us to solve this. Solve means to make the unknown quantity the subject. So the unknown quantities are R. We need to make it the subject. So we need to group all the terms in R on the left side or on the right side and make it the subject. So what I'm going to do, I'm going to expand out this side first. So it's going to become R plus 3 equals 3R minus 15. The 3 times this minus 5 is the negative 15 there. Take this R and bring it over here. I get R minus 3R equals, take this 3, take it over there. I get minus 15 minus 3. This becomes negative 2R. R minus 3R is negative 2R. So I get negative 2R here. And this side is given negative 18. Negative 18. Then I just need to divide by this negative 2. So the R becomes negative 18 divided by negative 2. The negatives cancel each other, and the 18 divided by 2 is 9. So the R equals 9. If you do it another way and get 9, no problem, because I could have grouped my R terms on the right side instead. But that is it. R is equal to 9. Done. Next question. They want us to make this K the subject. So we need to transpose everything away from this K right here. First thing I'm going to move is this 3t. I'm going to get 2a minus 3t equals pi times k squared. When I take the 3t and bring it over here, it becomes a minus. That's it. The next thing I want to move is this pi. I have to divide both sides by the pi to get rid of it. Shortcut is to say we take the pi that is multiplying over here and divide it under this side. That's a shortcut. So we're going to get k squared equals 2a minus 3t over the pi. And then now to move that square, the square root, or the inverse of square is the square root. So I could square root the left side, the right side, and also square the left side. And this square root will cancel off that square. All right? Put this in red so you can see it better. So again, to get rid of this square, we're going to square root this side, but we have to also square root the other side. And the square here, we cannot eliminate that square. The square root will eliminate the square, left with a k. So that's what basically doing, that I've shown in red. Square root both sides. Let me leave that in red. So the square root will drop off the square, and so the k becomes equal to the square root. The square root over here is gone over the square, you know. But the square root remains. And square root over everything. 2a minus 3t over pi. And because them say put it as a subject, I'm just going to turn this around and put the k on the left side. So I can say, therefore, k is actually equal to the square root of 2a minus 3t divided by pi. The thing is, when I'm trying to make something the subject, I like to just transpose everything away from the thing that I want to make the subject. That's why I do it this way. Just move everything. So when I had this expression right here, my aim is to leave the k by itself and just move everything away from it. Move that 3t, move the pi, move the square. That's how I like to proceed. Instead of moving the pi k. Some people try to take the pi k squared and move it over here. You don't need to do that. Leave it where it is and just move everything away from it. All right? And you get what it is. Simple as that. All right, that done. So you're supposed to get this as the answer. All right? That is that. Or anything that will be equal to that is correct. Next question. A farmer plants 2 crops, potatoes and corn. He says he plants them on a 10-acre piece of land. That's a limitation, you know. 10 acres, the total acreage on this piece of land. It says the number of acres of corn, C, must be at least. Now, at least means greater than or more. Equal or more, I mean. At least means that amount or more. So, for example, at least 10 means 10 or more. So, at least means equal to or greater than, right? That's what the term at least means. Twice the acreage of potato. So, this is the acreage of corn, which is C. It has to be at least means greater than or equal to. Twice means 2 times. 2 times the acreage of for potato, which is P. That's inequality on this line, you know. And then the inequality on this line is that the total acreage was 10. So the acreage of corn plus the acreage of potato must be less than or equal to the total acreage available, which is 10. Those are the 2 inequalities, you know. See them there? What them? Let me just move this one down here now. Those are the 2 inequalities. Simple as that. If you only have 10 acres of land, they can't plant more than 10 on it. They can plant 10 or less. So the total acreage of corn plus the total acreage of tomato has to be less than or equal to the acreage available, see, on a 10-acre piece of land. Is that linear is that inequality this? Those are 2 inequalities. And the question down. That's all I wanted. They didn't have to do anything else with it. That's it. Moving right along. Next question, number 3. Moving through this paper rather quickly today. The diagram below shows a hexagonal prism. So remember, when you have an object like this, the formula that governs what you do is the volume equals the end area times the length. The curved surface area, which is the area on the side, the face around the side of the object. The area of the face around the side can be calculated using the perimeter of the end. That's what P is, the perimeter of the end, the cross-sectional end. Perimeter of the end times the length. That gives you the area on the side. And then total surface area, which is the area of all the faces now, is equal to the curved surface area, which is the area on the side, plus 2 times the end area. 2 times A. The A is the end area or the cross-sectional area. We're talking about these 2 ends, the end at the front, the cross-sectional area, at the back and at the front, those 2 areas. So you're adding those 2 areas to the area around the side, this curved surface area. Remember that this curved surface area is just the perimeter of the end times the length. All right, let's go. I think we're doing this topic later. That's what I want us to do. First part says, complete the following statement. The prism has how many faces? What a face? A face is a flat, a plane side. So how many sides are around the, how many it has around the side? It has 6 around the side, right? And it has 2 at the ends, right? It has 6 around the side. 1, 2, 3, 4, 5, 6. 6 faces around the side, 1 face at the back and 1 face at the front. So it has 8 faces. So the answer right here is 8. How many edges? What are the edges? The edges are the lines joining the sides or the faces. The edges, they're represented by straight lines in this diagram. So the edges will be, for example, these straight pieces here. You have 6 of them around the side. 1, 2, 3, 4, 5, 6. 6 around the side. Then you have 6 on this end. 1, 2, 3, 4, 5, 6. I have 6 at the back. 1, 2, 3, 4, 5, 6. That's 3 6s we have. 18. So we have 18 edges in all. 6 around the side, 6 at one end, and 6 at the other end. So that's 18. Then the number of vertices. The vertices are the points where the edges meet. So like here, these are your vertices. You have 1, 2, 3, 4, 5, 6 on that side, on that face, on that end, and 1, 2, 3, 4, 5, 6 more at the other end. So you have 6 at this end, 6 at that end. So that's 6 and 6 is 12. 12 vertices. So the vertices are like some points where the lines meet. Those are vertices. Done. 3 marks for that. Nice and easy. That's all I wanted. That's all the question I wanted. They want a surface here or nothing. That was it. Nothing missing. Jeez, Somebody write that for. I thought they was going to ask us for volume and all these things. All right. Easy question. Well, this question says, a sports club owns a field PQRS in the shape of a quadrilateral. A scale drawing of the field is shown. And the drawing is 1 centimeter to 10 meters. So in the exam, you basically have to be working with the scale in the actual exam. Understand? On the actual paper, this is to scale. So if you measure 1 centimeter on it, it means that 1 centimeter represents 10 meters on the field. If you measure 2 centimeters on the diagram, that will be equivalent to 20 meters on the field itself. All right, this is a scale drawing. On the exam paper, that would have been a scaled drawing. It says, in the following part, show all construction lines. So this is a geometry construction question. It said the field is to be divided with a fence from P, from here, to the line, to the side RS. So I want a fence from P to RS over here, so. So RS here, so. So I want a fence down the middle here, so. All right? So that it divides the sports, so that different sports can be played at the same time. So that I want to play some sport over here and some sport over there, right? So I want to divide the field with that line, with this fence that I've left on the screen in blue. It says, each point on the fence must be the same distance from PQ. Okay. Each distance on this fence, right, must be the same distance from the line PQ, which is this line over here, and the line PS, which is the line over here. So for example, if the fence is here, for example, let's give an example. If the fence is here, for example, and you have a point on the fence here, what I'm saying is that the perpendicular distance from this line to that point must be the same here. So this distance must be equal to this distance. But that's going to be the same. It means that this line has to divide the angle over here equally. That's what it means. If this distance is going to be equal to this distance, then this line here will have to divide this angle equally. The blue line has to divide this angle equally. So to draw this blue line or to construct this blue line, we just need to bisect this angle. We need to bisect this angle. We need to bisect that angle to get the line right down the middle here. That to be such that this distance and that distance equal. And it's a perpendicular distance I want, you know. So we need to draw a bisector of that angle. Construct a bisector of this angle right here. That's what we need to do. All right. I'm not going to do it with the protractor. I'm just going to show you what you would have to do. What you'd have to do is from this point, open your compass and you'd make an arc, like so, for example. Make an arc. Remember, that's where you bisect an angle, right? From this point, you make an arc, like that. And then from here, you're going to bisect this arc now, these 2 points. These are different color. You're going to bisect this arc now, because this arc now represents the angle. From here to here is the arc representing the angle. We need to bisect that arc from those 2 points that I'm marking in purple. So you're going to put the compass here and make a small arc from here up here this way, like so. All right, so from this point, you're going to open your compass and make an arc this way. And from here now, you're going to make an arc this way. From here, you're going to make an arc this way. And then your bisecting line that you want is going to pass right down here, right to the intersection. So your bisecting line is going to go like this. Draw the bisecting line in the red for you. Right down the middle here. That's the line that you want. That's where the fence will have to be. So basically, to get the fence, you have to bisect that line, but that angle, bisect this angle that marked in blue. And that's how the fence will have to be. This is the fence. This will be the fence that you have to put up. That red line is the fence. That's the fence that you want to divide the thing. It has to bisect the angle, and it's such that, let me show it now. The distance down here is a different color. Let's use this orange. The distance here, the perpendicular distance here to any point on it, like so to here. The same distance to this line over here. That's what they said they wanted. So this distance and this distance is the same. That red line will do that for you. You have to bisect the angle. All right. The next part wants us to measure it. It says write down the length of this fence in meters. Write down the length of the fence in meters. So I think when you measure this line, I think you get 7.3 centimeters. I think when you measure the length of the line, if you do it on the actual paper, not on the one that I copied for you, it will be 7.3 centimeters will be 73 meters. Remember, 1 centimeter is 10 meters. All right, and I want the actual distance in meters. So it will be 7.3 meters on the fence. 7.3 centimeters on the drawing. Which is equivalent to 73 meters actual. So the answer is supposed to not 75, 73 multiplied by 10. So if we do the actual exam paper, guys, that's what you're supposed to get. All right, let's continue. So basically, to get this 7.3, you know, you basically measure the length of this red line with your ruler. That's what you have to do. All right, that finishes that part of that question. Then we'll come to this quadrilateral PQRS and its image P prime, Q prime, R prime. This is clearly an enlargement. From this to this is clearly an enlargement. An enlargement has a scale factor and it also has a center. If you want to describe it, you have to give the scale factor and the center. You can look at it and know what the scale factor is right away and also locate the center. All right? So if you look at this side, for example, PQ, see that it is tripled. So this length was 1, it is now 3 units. So the scale factor is a value of 3. In addition to that, the scale factor is positive. Why? Because the image and the object pointing in the same direction. So for example, P to S is pointing to the right. P prime to S prime is also pointing to the right. Right? So you know the scale factor is positive. It was not inverted. So the K is a positive 3. Let's make a note of that. So the scale factor is a positive 3. Then an enlargement will also have a center. Makes sense to just work it out from now on because they're going to ask you that, right? Where's the center? To find the center, you join corresponding points and extend them back until they meet. So for example, P prime and P. So that is on this line right here. So you know the center point is on this line. And you can join Q prime and Q. So we join Q prime and Q and extend it back. It looks like it's coming out here. That's right. We're going to check if this is the correct point. Just that I don't have a ruler on us, so I'm trying to estimate it. The straight line through here, it looks like that. Or it could be out here. Let's see which one it is. Let's assume it is this one. Kind of difficult to tell because I don't have a ruler. All right, let's assume it is this one. I can check it. Let me tell you, I want to check it. I know the scale factor of 3 also affects the distance from the center of the enlargement, right? So for example, the distance from, if this is the center, the distance to P right here, so it's 2 units. So the scale factor is 3, I will notice 3, then the P prime is going to be 6 units. See, from P to P prime is supposed to be 6 units. Let's check it. 2, 4, 6. Yes, it is 6 units. So confirm that that is the center of the enlargement. But the scale factor does not only affect the size of the object, it also affects the distance from the center to the object. So the distance from the center from the center to a point was 2, and the scale factor is 3. That distance is now going to become 6 to the image point, the corresponding image point. So that's confirmed. But if you draw this with a ruler, guys, if you draw this straight line with a ruler and extend it down, then you won't have to do that check. It will just pass through here for you. All right, so that is the point. What point is that? That's negative 4, 1. Negative 4, 1 is the center of the enlargement. I know they're going to need it. They must need it. That's all these questions are all the time. They have to describe it. They're going to need that point. And the scale factor is 3. All right, let's see what I want us to do now. So let's find that out from the get-go. Question says, write down the mathematical name for the quadrilateral. That's a trapezium. See? That's one pair of parallel sides. That's a trapezium. Easy. A trapezium. Next one. It says PQR is mapped onto P prime, Q prime, R prime by an enlargement with a scale factor of K, which we know that the K is 3. About the center CAB, we know that this point is minus 4, 1. So we know that the K is 3. And at the point CAB is actually C minus 4, 1. Can work out already. So the center of the enlargement is this, and the scale factor is 3. Question says, use the diagram to determine the value of A, B, and K. So we have it here. K is 3, you can write that down. The A is negative 4, because they call the point AB, but we know it's actually negative 4. So the A is negative 4. And the B value, the Y value at the center point is 1. So the B is 1. That's what they're asking us for, those values. A, B, and K. See them there? That is it. Same thing. Let's continue. We'll come to number 4. That's a functions question to begin with. They give us one function, f of x. F of 4 plus f of minus 4. So this is equal to the f of 4 first. We're going to plug the 4 here for the x. It's going to become 2 times 4 plus 7 over 5. Plus, that's this plus. Now one f of negative 4, means I'm going to plug the negative 4 in here. So it's going to become 2 times negative 4 plus 7 over 5. Now these two fractions have the same denominator, so we can literally just add up the numerator one time and put the answer as a common denominator of 5. So the answer is going to have a common denominator of 5. This is going to be a plus 8 and that's going to be a minus 8. So they will eliminate each other, the plus 8 and the minus 8. And then this 7 and 7 is going to give me 14. So the answer is 14 over 5. That is it. All right? That is that. The 2 times 4 and the 2 times minus 4, they eliminate each other when you add the fractions. All right, next question. It says, calculate the value of x for which f of x is equal to 9. What is f of x again? It is 2x plus 7 over 5. So here we're solving 2x plus 7 over 5 equals 9. That's what we're solving. All right, so we're solving for x. First, we're going to multiply the 5. So we're going to get 2x plus 7 equals 5 times 9, or 9 times 5 is 45. We're going to subtract the 7, so we're going to get 2x equals, we subtract 7, you're going to get 38. Subtract 7. And you have to divide by this 2. So you divide it by 2 now, so you're going to get x equals 19. Those are the steps. So here first, we subtract 7, and then we divide it by 2 for to write out what we did. So x equals 19. All right? This part now says, hence or otherwise, determine the value of f to the minus 1 of 9. Let's use a hence method. Let's use a hence method. What we know from up here is that since f of x is 9, it means that since f of x is 9 gives us x equals 19, it means that f of 19 is 9. So see here, f of 19 is 9. So from up here we have f of 19 is 9. Because remember, we solve this up here, f of x equals 9, where the x equals 19. So we can take 19 and put here for the x. And so f of 19 is 9. To get this, I can now inverse this side. So the 19 is going to be f to the minus 1 of the 9. Because if f of 19 is 9, then f to the minus 1 of 9 is 19. So that's the answer for this, 19. So we can say, therefore, f to the minus 1 of 9 equals 19. That is the answer. 19. Reverse the mapping. All right? If f of 19 is 9, then f to the minus 1 of 9 is 19. If f of 19 is 9, see, if f of 19 is 9, then f to the minus 1 of 9 is 19. If the mapping is reversed. It's something like this, you know. Look, let me show you a diagram of it. What this means is that 19 is mapped onto 9 with the function f. So the 19 is going to map back, the 9 is going to be mapped back onto the 19 with f to the minus 1. That's what this is. F to the minus 1 of 9 is equal to this 19. So like a diagram of it. So we apply f to 19, we get 9. So we apply f to the minus 1 to 9, which is what this is asking us. We're going to get 19. So the answer is 19. So this diagram kind of shows what is happening. 19 is mapped onto 9 with the f. So the f to the minus 1 maps the 9 back onto 19. Anybody got 19 for that answer? Good. So whichever method you use to get it, no problem. Some people might have found the f to the minus 1 of x first and then plug the 9 in it. That's fine. All right, let's continue. I like these questions because they give you the lines, you don't have to calculate nothing. After the time, you don't have to calculate nothing because you have the graph looking at. Question says, diagram below shows two straight lines, L1 and L2. So this one up here is L1. This is L1. And this other line is L2. So L1 is this one, the first one with a negative gradient. It says, L1 intersect the x-axis and the y-axis, x and y-axis at 4, 0 and 0, 2. That's right here, 4, 0 and 0, 2. So they're giving us those 2 points, which you can see as well. And it says L2 intersects the x-axis and the y-axis at 1.50, 0, negative 3. That's this one. 0, negative 3, and right here is 1.50. So what they have said is on the diagram already. All right? So what they have said is on the diagram. Question says, determine the equation of line 1. Easy. To get the equation of this line 1, we need to know two things about it. We need a gradient and a point. Or we need a gradient and a y-axis intercept. Since you have the graph, you can see them. The y-axis intercept clearly is 2 for that one, right? So for line 1, we're going to use y equals mx plus c for line 1. And clear that the c is equal to 2 right now. Line 1 crosses here at 2. The next thing we need is the gradient. We can count out the gradient between any 2 points. So for example, from this point to this point, I will know the coordinates for sure. Look at it, you know, any 2 points. Going from left to right, we need to count the rise and count the run. Let's do it in red. Between any 2 points, between this point and this point. Going from left to right. How do I go from this point to this point? What is the rise and what is the run? I have to come down 1 unit. See? 1 unit, because this is 3 right here and this is 4. So I come down 1 unit. Because I'm going down, that's a rise of -1. Then from here now, I have to run here now 2 units. I have to run 2 units to the right. Go from this point to this point. So this is my rise, and this is my run. So my rise is -1 and run is 2. So the gradient is -1/2. Simple as that. So the gradient on this line M, which is rise over run between any 2 points. I chose 2 points. My rise was -1 and my run is 2. That's the gradient. I'm going to put here that for the gradient and put this 2 here for the C. And then I'll be done. So I can say, therefore, the equation that they want is y equals -half x plus 2. That's the equation. If you get it some other way, fine. But when they give it, when they have the graph looking at, it don't make no sense to do it any other way, really. Look for the y-axis intercept, that is the C. Count off the rise and run between 2 points. That is the gradient. I remember, always do it so that you're going from left to right and along the line, from left to right. And you must know that that line has a negative gradient because it's sloping down. You have to be able to recognize those things, right? Because a negative gradient because it is sloping down. All right, what is the one? It says, what is the gradient of line 2, given that line 2 and line 1 are perpendicular? So let's call this up here gradient line 1. Since it was line 1, let's put a 1 on it. Line 1, this gradient. Let's call it line 1. All right, let's put a 1 on this as well for line 1. M1. Let's put C1 for the cis line as well. C1. So we're talking about line 1. Don't you know we're talking about line 2. They tell us that they're perpendicular. So it means that the gradient of line 2, that's for the gradient. The gradient of line 2 is -1 over the gradient of line 1. Remember the gradient of line 1 is -1/2, you know. So to do this calculation on line 1, to get the gradient of line 2, you can flip this and change the sign. If you flip it first, it's going to become -2/1, and you change the sign to a +2/1, which is a +2. So the gradient of line 2 is actually 2. But then you have the line, you could have counted it off as well. Look, so line 2 here, you could have chosen 2 points on it as well and counted off the gradient. Like, for example, from here to here, between these 2 points, I would have, my rise would have been 2 units, and my run would have been 1 unit. See, rise 2, run 1. So the gradient would have been 2/1, which is 2. So you could have calculated it as well, and counted it off on the line. In any case, the gradient of line 2 is 2. Anything else? No, the question then. All I wanted was a gradient. That is it. All right, next question. Number 5. It says, a group of 100 students estimated the mass in grams of a seed. It says the cumulative frequency curve below shows the results. So they give us this cumulative frequency curve for the 100 students. This is the mass of the seed that they estimated. All right. Remember, this graph either shows less than mass or it shows less than or equal to mass. All right. I find that nowadays the most setting graphs that show less than or equal to in recent times. All right. That's what I find recently. So remember, it shows either less than mass or less than or equal to mass. The mass that estimated. It says using the graph, use the cumulative frequency curve to estimate the median. So the median is the mass that was estimated by the 50th student, because there are 100 students. The one in the middle estimated the median mass. So that's the 50th student. So right here is the position of the second quartile, which is the median. That's not the quartile, that's the position of it. To know what the mass is, you have to come across on a graph. That the 50th student estimated and read that mass down here. You have to make sure you read the scale of the graph properly. So if you look at it, there are 5 lines between 0 and 1. So it's like 1 divided by 5, which is 0.2. So each single line there is 0.2. So it says 0.2, 0.4, 0.6, 0.81. So every line is 0.2. So here then has to be 3.2. That mark right there is 3.2. Right here. If I extend it down, it is 3.2. That is our Q2. 3.2. So it's 3.2 grams. So the median is 3.2 grams. So this is the median Q2, which is 3.2 grams. But I got that? Good. Next part wants us to tell them the upper quartile. The upper quartile is the mass that was measured by the student that is in the 3/4 position or the 75th percentile position. 3/4 of 100 is 75. So you're going for the 75th student. What must the 75th student measure? So it's 70 here and 80 here. So 75 is right in the middle here. So 75. That is the position of Q3. Why is it 75? Because it is 3/4 of 100. Or 75% of 100. That's the upper quartile position. All right? And so we're going to see the mass measured by the 75th student. So you come across right in here in the middle. And that is right in the middle again between those two. So I'll come down here now in between here. Right in between those two lines. Use your ruler and draw it all the way down. That is the upper quartile. Now this is 4.2 and this is 4.4. So in between them is 4.3. So the mark that I want is 4.3. So this now is the upper quartile mark, which is 4.3. That is our Q3. Our upper quartile is 4.3 grams. 4.3 grams, upper quartile. So down here we can write that Q3, the upper quartile, is 4.3 grams. Easy like that. Then down here now, they want the semi-interquartile range. Now remember, I know the semi-interquartile range, be careful now, is the interquartile range divided by 2, or half the interquartile range. The interquartile range is Q3 minus Q1. That's interquartile range, and we're dividing it by 2. We know the Q3 already, we just worked out already, 4.3. And so we now need to calculate or find the Q1, first quarter, to finish this calculation. All right, so let's find Q1, so we can put it here. So come up back on the graph. The portion of Q1, if it's 100 student, is 1/4 of 100. So the 25th student. So this is the position of Q1. The 25th student is in the first quartile position, right here. Halfway between the 20 and the 30 is right here, the 25th student. That now is the position of Q1. That's not Q1, that's the position of Q1, the 25th student. So you come across on the graph, you meet the graph right here, and looks like it is right in between here as well, based on this. Now this is 2, this is 2.2, this is 2.4. So right here is 2.3. That is Q1, 2.3. So Q1 is 2.3. So this calculation then, see there, Q1, let's put it up here. Q1 is 2.3 grams. So this calculation then becomes 4.3 minus 2.3 divided by 2. Let's make this a little smaller. All right, that becomes 1. Because this up here says 2. 2 over 2 is 1. So I'm getting 1 gram. But that? Go on the bright, man, on the bright. All right, very good. All right, that is it. Next question. It says the number of students who estimated 2.8 grams or less. You see, less than or equal to graph forever now. This means less than or equal to 2.8 grams. You want to know how many students measured less than or equal to 2.8 grams. The graph is going to show you that because the graph is showing how many students measure less than or equal to any measurement. All right? How many students measure less than or equal to any measurement in grams. So we want to find 2.8 and count how many students that correspond to. That's all we have to do. No adjustment needed. We have to show you. So looking for 2.8. Let me use a different color for this part now. Let me use the blue. So 2.8 to be right here. That is 2.8. All right. So we're going to mark this as our 2.8. 2.8 grams, and it's on this line. So you come up onto the graph on this line. It's a 2.8 grams line. If I look at it, I think it gone to about the middle of this piece right here. So I'm going to mark it as this. Now this is 32, 34, 36, 38, 40. So I am between 38 and 40. So I'm 39. So I'm putting 39. 39 students. All right? So all the students down here, all the measurements down here, or less than or equal to 2.8 was measured by all the students down here. 39 of them. All right, so that says 39 students. Somebody get anything else? Somebody put 38? Some person might have come here, come across here and put 38. I guess if you put 38, they give the marks still, right? So I'm going to put 39. So this is 39 students. 39 students. But go to that. You want to put 39 as well? Huh? I put 38. Put 38. All right. They give it a marks for the 38 still because it's the estimate. I kind of look close. All right. All right. Good. We have to look at it carefully. This question down here says now, use the cumulative frequency curve to complete the frequency table. So what we want to know is how many students are in between 2 and 4. How many students measure between 2 and 4? And how many students measure between 4 and 6? Remember, the total must be 100. You know? Remember, it's 100 students. So if you find one of them, you can tell the difference to get the next one and just kind of double check it, right? Let's look at it. Between 2 and 4. Let's see how many students measure between 2 and 4 grams. Let's look at it. Between 2 and 4 on the graph. All right, let me show you now. Let me use the purple. So 2 was the mass measured by the 20 persons here, right? So that, and 4 now was measured by how many persons? Come up on this line for the 4, and so much people in there in that range. And to me, this is coming up right in between here, so. That is 69. This is 68, you know. 70. This is 69. 69. So 69. So the measurement between 2 and 4 was measured by the students between the 69th and the 20th. So 69 minus 20, that's 49. 49 people in this range. Measure between 2 and 4, that's 49 students. So I'm going to put 49 right here. 49. Now I can add up what I have so far and then subtract from 100 to get this figure. Let's do it and then double check it to make sure it's right. Let's do it that way. So what is work out to? So this and this make 50. Then this and this make 70, 76. 76 from I think there's 34. Right? So I'm saying that this will be 34. Someone can check that for me? Yeah, because this will be 40. And this and this will be 50. No, not 20, 74. Wrong. It's 24, 24, 24, right? So it's 24. I'm saying it's 24 it's supposed to be. But I'm not just gonna accept the 24. I'm gonna check it, see if it's actually 24 in between the 4 and the 6. Right? We already know that this end is 69. We just need to see what the 6, how many persons measure less than 6 now, right? Less than or equal to 6. All right, let's go up on the graph now. We're trying to check for this 24. Once you see there are 24 people between the 4 and the 6, so we need to go up to the 6. So let's look at it just to check. Just to check. So see the 6 here now. We're going to see how many persons measure less than 6. So you come up on this 6 line, 6 gram line, all the way up to the graph. Come up on the graph. If I zoom in, it's right in between here again. See, I like to go in between these lines. So it's in between here again. So I'm coming across on the graph to see how many persons that is. Now this is 90, 92, this is 94, 92 and 94. Halfway between 92 and 94 is 93. So right here is 93. So the students in between is this, you know. Remember, this was for the 6, and this was for the, no, this was for the 4. This is now for the 6. So you want the difference between them. What is that? 93 minus 64 is how much? 93 minus 69, sorry. 93 minus 69 is how much? Yeah? 24, see it? 24. So 24 is correct. You see that? We'll just check it and make sure it is correct. 93 minus 64, 93 minus 69 is the number of students between, see here, who measure between the 4 and the 6 grams. See here, between the 4 and the 6 grams on the table. Was 24. So when you complete the table now, that is it. All right, so 49 here and 24 here. Now, if you do it and you get like a slightly different values because of the graph, fine. But remember, the total must add up to 100. So, for example, you might have gotten 50 here, so, and 23 here, so, for example. CSEC cannot give you the marks still. All right, but try to get it accurate now, please. Let's try to get it accurate. All right. Next part now says a student is shown at random. Find the probability that the student estimated the mass to be greater than or to be greater than 6 grams. So this is when they said the mass was greater than 6. All right. So that's what the base basically saying here. This is saying that the mass is greater than 6. So it's basically says here, this is the first time when it became greater than 6. You know? So this inequality is asking for these persons. These are all the measurements that were greater than 6. See, the mass is greater than 6. It's greater than 6 here first, and then all the way up to 10. So these are the students who measured it greater than 6, 7 of them. So the probability of measuring a mass greater than 6 becomes 7 out of 100. That is the answer. 7 out of 100. It's in the table. That is it. Everybody got that one? 7 out of 100 students measure the mass greater than 6. All right, so that finishes that question. Number 6. Number 6 gives this diagram. It said the radius of each circle in the rectangle WXYZ shown below is 7 centimeters. So see here the radius is 7 centimeters. It means that the diameter is 14. And they are joined side by side. The circles fit exactly in the rectangle. So they go wall to wall. So each of these is 14 across, diameter across. And it's 4 circles across. So this dimension is 4 times 14 centimeters across here. And on this way again is 14. 14, 14, 14. So down this dimension, this way, is 3 times 14 centimeters. So the overall length is 3 times 14 and the width is 4 times 14. We can work them out. 4 times 14 is how much? Huh? 56. Same as 8 times 7, right? This is 56. So this is 56 centimeters. And then the 3 times 14 is how much? How much? So this is 42 centimeters. So the length of the rectangle is 56 and the width is 42. So you establish that. Question says, show that the area of the rectangle is this. All right, so the area of the rectangle is this times this. And I'm leaving those markings on my diagram to see if I get my 42 or my 56. I'm leaving them on it. I'm not taking them off. Those purple and red markings. I'm leaving them on it. Right? That's a part of my solution. And so I'm going to write the area of the rectangle. Let's call it area R. Is 42 times 56. And I'm sure it's going to work out to 2352 centimeters squared. Did it? Is it? Yes. Let's double check it. Make sure. Not taking any chances. So it's 42 times 56. Good. That is it. 2352. All right. So that was shown. That was shown. For 2 marks. Next part says, calculate the area shaded. So look at the diagram. To get the area shaded, we're going to have subtract the area of those 12 circles. There are 12 circles in there. 4 across by 3 down. That's 12 circles in there. We're going to have to subtract the area of the 12 circles from the area of the rectangle to get the area shaded, right? Because it is the circles that are not shaded. Right? So see here then, the area shaded, let's write it like this. Area shaded going to be equal to the area of the whole rectangle minus 12 circles. 12 times the area of each circle. And there are 12 circles in there. That's what they're calculating. The area of the rectangle just worked out a while ago. It is this. 2352. So it's 2352 minus 12 times. What's the area of a circle now? Pi r squared. And the radius is 5. The radius is 7 for each one, right? So it becomes pi times the 7 squared. That's pi r squared. Let me put the 22 over 7. The pi is 22 over 7. Let me write here that the area of a circle is just pi r squared. Put here in red. The area of a circle is pi r squared. And r is 7. That's what I have here, pi r squared. So I put this in the calculator and I'll get my answer. One calculation I'm going to do. Not going to complicate it. Let's write this 2 better. It's going to be an exact value actually. As the 7 is the radius. All right. So it becomes 2352 minus this 7 is going to cancel with one of this 7. So I can just write 12 times 22 times 7. 12 times 22 times 7. So I get 504 centimeters squared is the area shaded. Y'all got that? Got that? Beautiful, beautiful. All right. Next question. Diagram below drawn to scale shows triangle MNP in which angle MPN is equal to angle PMN is 52 degrees. So this is an isosceles triangle. So the side opposite this angle over here is equal to the side opposite this angle over here. So these two sides are equal. So it means then, since that this is 12.5, as I said, this side is also 12.5. So I'm going to put it on the diagram right now. As you know it to put on the diagram. So this side is 12.5. And because this is isosceles and these two angles are known, the third angle up here is going to be 180 minus those two, don't it? Don't it? Let's work it out from now. Total angle in the triangle is 180. So it's going to be 180 degrees minus the 2 times 52 degrees. Now the 2 times 52 is 104. So I'm getting 76. So the angle inside here is 76 degrees. All right, so we know that. Let's see what I want now. It said name the type of triangle it is. Two sides equal, it is isosceles. Two sides equal, two angles equal. Determine angle PNM. That's what we just did up here, sir. No? That's what it is. So it's 180 degrees minus 2 times the 52 degrees, because 2 of them. That gives us the 76 degrees. Nice and easy. Next part says we have to calculate the area. So to calculate the area, we're going to use the trig formula for the area of a triangle. Two sides with the angle between them. So it's half AB sine C we're using. Half AB sine C formula. So the area formula we're using is half AB sine C. That formula. Just as the A and the B is the same, right? The A and the B is the same, 12.5. So it becomes half 12.5 squared times the sine of the angle between them is 76. So this becomes half 12.5 times 12.5 becomes 12.5 squared times the sine of the angle between them, which is 76 degrees. So we're going to put this in the calculator and work it out. Let's go. So the half is same as 0.5 times the 12.5 squared times the sine of 76. Make sure the calculator is in degrees. See there the DEG up the top there. Yes, it is. And I put 76 degrees there. So I'm going to 75.8. I'm going to give it to 3 significant figures. 75.8 centimeters squared is the area of that triangle. Got that? What? Going good. Next question, number 7. It says a sequence of figures is made up of stars using dots and sticks of different length. I don't think I need a calculator yet. All right. So the first 3 figures in the sequence are shown below. They don't want us to draw a 4th figure for this one. Wow. Why get to it? They don't want a 4th figure. Study the pattern of numbers in each row in the table below. Each row relates to a figure in the sequence of figures it should be started above. Started above. Some rows have not been included. Complete the rows marked 1, 2, and 3. All right. So let's look at the pattern so we can fill out the formula line first. You know we like to fill out the formula line first, especially for the types where we're increasing by the same number each time. So in this column, we can start increasing by 12, obviously, right? So the formula starts with 12n. N is a figure number, right? N is a figure number. So the formula starts with 12n. And the first figure actually has 12, so you don't have to add anything. Just 12n. 12n, because 12 times 1 is 12. So the formula for that column is 12n. Then over here, it's increasing by 12 again. See, increasing by 12 again. But the first figure has 13. So it's going to start with 12n again, because increasing by 12. But the first figure has 13. 12 times 1 is 12. If I add 1, so it's 12n plus 1. Becomes the formula here. 12n plus 1. So that's a 2 formula. That will help you to fill out the rest of the table, right? So let's go. So for the next figure, we just need to add 12 to this and get 60, or we drop the 5 on the formula. 12 times 5 is 60. So this is 60. And if you notice, this is always 1 more. So this is 61. This is plus 1. So this is 61. Here again, if this is 56, then here's going to be 1 more than it. 156, going to be 157. I remember now it is a 12n that is equal to 156. So right here, we know that 12n equals 156. So the n equals 156 over 12. What is that? 13? Oh, 157, my mistake. 157, thanks. Right, so this is going to be what, 13? 13. Yeah, if you drop it down here, you're going to get it. All right, so that is it. Table done. Nice and easy. Next part, we have another part. It says, the sum of the numbers of dots in two consecutive figures are recorded. It said this information, talk about the number of dots. Remember the formula for the number of dots, right? Number of dots. Which formula, number of dots? This one. This formula for the number of dots. So let's start with that. The number of dots, remember, is 12n plus 1. All right, let's remember that, right? Number of dots in figure n is 12n plus 1. So here now it's like you have figure 1 and figure 2 added together. So total number of dots in those two consecutive figures is 38. Then figure 2 and figure 3 added together. And so it is 25 plus 37 equals 62 and so on, right? And I said determine the total dot in figure 7 and figure 8. So what I can do to do this, since I have my formula now, right here now, this is when n equals 7 and this is when n equals 8. I'm not going to complicate it. So this one is for n equals 7 and this is for n equals 8. And I'm going to add them. So that total is going to be, plug the 7 in here. So first I get 12 times 7 plus 1. That's a figure 7 plus, for figure 8, no, it's going to be 12 times 8 plus 1. I'm not complicating it. So add up for figure 7 and add up for figure 8. That's going to give me my answer. What is our work out to? Huh? The show said right? All right, let me check it myself. I'm not going. I want to check it. All right. So it's 12 times 7 plus 1 plus 12 times 8 plus another 1. 182 again? I don't know a while ago. 182. All right, beautiful. Then here now they say what is in figure n and figure n plus 1. So it's simple. Figure n will be 12n plus 1, right? That is figure n. Plus figure n plus 1 now, all that happens that this n becomes n plus 1. So it becomes 12n plus 1 plus 1. But can you understand that? All right? It's not complicated. So this is for figure n plus 1 because the n becomes n plus 1. Remember the formula is d equals 12n plus 1 n. This is a formula for figure n. So this comes back as is because that is figure n right here. But this now is for figure n plus 1 because your n now becomes n plus 1. That is it. So we just need to add up these now and see what we get. So let's expand this out. 12n plus 1 plus this becomes 12n plus 12 and 1 make 13. Then this and this make 24n. So you get 24n plus 14. That's the answer. 24n plus 14. Y'all got that? You get everything? All right. All right. That is it. So remember, this one is for figure n plus 1. Let me separate them. This one is for figure n plus 1. And this one is for figure n. And this can just add them up together. All right. Simple as that. Moving right along. Number 8. We are with section 2 already. Flying through this paper, man. Finishing record time. Started late, you know. All right. This question says, They give us these two simultaneous equations to solve. One is a curve and one is a line. But look at this, it's kind of easy, you know, because x is a subject on this one. And you have x on a subject on this one as well. So we can basically just substitute for the x and take all of this and replace the x right here. All right, so we're going to substitute for the x. This one kind of easy. So we're going to substitute for the x. So this line is saying x equals this. I'm going to replace the x right there with it. So when I do that, I'm going to get y squared plus 2y. That's I'm going to find my y values first. Y squared plus 2y plus 11 becomes equal to, and where the x is now, I'm replacing it with 5 minus 3y. So I get that equation in y. It's a quadratic. I'll put it in the standard form. So I'm going to take this minus 3x, bring it over here and add to this 3y, and add to that 2y, I'm going to get 5y. So initially, I'm going to get y squared plus 5y. And then this 5, I'm going to come over here and subtract from the 11. 11 minus 5 is 6. So I'm going to get plus 6 equals 0. And this can factorize easily, you know. Because the factors of the y squared is only y and y. The factors of 6 that add to 5 is 3 and 2. 2 and 3. Signs are the same, everything positive. Positive, positive. So this factor, if it equals 0, I'm getting y equals negative 2. This factor equals 0. I'll get y equals negative 3. So now I need an x value to go with this and the x value to go with this. I'm going to substitute in them in this line. All right? In the line equation. So let me write it in red. I'm going to be subbing into the line that says x equals 5 minus 3y. That's what I'm going to be subbing into. The first value is where y equals negative 2. So where y equals negative 2, uses a work of the x. The x becomes 5 minus 3 times negative 2. This minus becomes a plus. That's plus 6. 6 and 5 makes 11. So this becomes 11. So 1 point is 11 negative 2. See here, 11 negative 2. You have to put the x value first in the bracket. So even though we calculated the y value first, you still have to put it second in the bracket. So this is 1 point. That's one answer right there. The other point is where y equals negative 3. Let's put it here. Where y equals negative 3, using this again, the x becomes, the x is 5 minus 3 times negative 3. This minus becomes a plus, plus 9. 9 and 5 is 14, so this works out to be 14. So the other point is 14 is x value, negative 3 is the y value. 14, negative 3 is the other point in the bracket. So these two are my answers. This one is an answer. And this is the other answer. 2 points. Those are my 2 points of intersection. That is it. Solve them simultaneously. Hope you all got that one as well. Everybody got that one? Nice. I'm not hearing for the online. What happened?
I got you, sir. I got you, sir.
All right. Good, good. All right, let's continue. Down here now, it's a quadratic function. Long time we don't do xt and yt. So it gives us this function, and it wants us to complete the square. Write it in that form. We're going to use xt, yt method. So instead of using the a and the h, we're going to set this up instead as a into x, remember, not plus, minus the x value at the turning point, squared plus the y value at the turning point. So instead of using this, we're going to be using it this way. When we calculate xt, that is the x value at the turning point. We calculate yt, that is the y value at the turning point. That's the method we're using. Now, we need the a, the b, and the c from the standard form to calculate xt and yt. So from this standard form here, the a is the coefficient of the x squared. So the a is 4. The b is the coefficient of the x. Now mind from the x is a -8. Don't ignore the sign. It's a -8. And the c is a constant term with the sign as well, -2. Let's write the formula for xt here. Let's write the formula for xt. The formula for xt that is going here is minus b over 2a, where we're using this format. If persons are using this format and using the h, it will be b over 2a. But in this class, we use a minus xt. So the xt is minus b over 2a. So this then is going to become minus, the b itself is -8. So it's minus a -8. Divided by 2a, which is 2 times the a. The a is 4. 2 times 4. That becomes a +8 over +8, which is equals to 1. When your xt becomes a whole number like that, you can find the yt easily by taking the same xt value and putting it in the function for the x. Because yt is the y value when the x value is xt. So we can calculate yt that way easier this time. So the yt is going to be f of 1 basically. The yt is going to be f of 1. We put 1 in the function. So it's going to be equal to 4 times 1 squared minus 8 times 1 minus 2. This is 4 minus 8, that's -4, and then minus 2 more -6. So the yt is -6. So we're going to fill this out now. So we can say, therefore, f of x in this format, using this format, f of x becomes equal to the a in front is 4, a is 4, bracket x minus the xt is 1. Don't forget to put on the square, and the plus yt is -6 minus 6. Y'all got that? Good. Huh? Then it says state the minimum value. The minimum value is the yt value. The lowest y value is the minimum value. They ask for the minimum point, the minimum value. So the minimum value is the yt value, the y value at the turning point, which is the -6. That is it. Just state it. No calculation is needed for it. It is the lowest y value at the turning point, yt. Continue down here. Determine the equation of axis of symmetry. Axis of symmetry is always x equals whatever the xt value is. That is the axis of symmetry all the time. Xt value is 1, and so it is x equals 1. X equals 1 is the axis of symmetry. X equals 1 is the equation of that vertical line to the turning point. X equals 1. Nice and easy question, this one. Then we come to this velocity time graph or speed time graph. Remember, on a speed time graph, gradient is acceleration. Area under the graph is distance traveled. All right? Remember those things. It says, the speed time graph not drawn to scale shows the 3-stage journey of a car over a period of 40 seconds. Determine the acceleration for each of the following stages. For stage 2, the one acceleration. Remember, gradient is acceleration. Gradient of an horizontal line is 0. So the acceleration on stage 2 is 0 because the speed is constant. So there is no change in speed. So in stage 2, gradient is 0. See there? Acceleration will be equal to gradient. In stage 2, the gradient is 0. So it is 0 meters per second squared. It is not accelerating. If it's going at a constant speed, it is not accelerating. Accelerating is when the speed is changing. When the speed is increasing, it is accelerating. When the speed is decreasing, it is decelerating or going through retardation. So up here at stage 2, the speed is constant at 12 right across it, 12 all the time. So it is not accelerating, so the acceleration is 0. Next one, stage 3. They ask us for the acceleration, so we have to give it as a negative acceleration. If that asked for the deceleration, would have given it as a positive. But because it asks us for the acceleration on stage 3, in stage 3, the acceleration is negative. Because this time speed is actually going down. So in stage 3, that acceleration again in stage 3 becomes the gradient. This is gradient, I-E-N-T. Which becomes again the rise over the run, right? Because it's gradient one, we're gonna put rise over run. In this case, the rise is actually a fall. It drops by 12 and it runs by 8. Drops by 12, that's a negative 12 over 8. So that in this stage 3, the rise is 12, but a negative 12 because it falls. And the run is from 32 to 40, that is 8. All right, so the rise becomes negative 12 over 8. What is that work out to? Negative 1.5, negative 1.5, negative 1.5 meters per second squared. Now, watch me now, guys. Remember, you know, the question that asks you for the deceleration in stage 3, you would not put the negative on it. Because deceleration already means that the speed is reducing. It is a rate at which the speed is reducing. That's what deceleration is. So if this same question is asked for the deceleration in stage 3, the answer would just be 1.5 meters per second. In fact, let me write it here so for you. The deceleration or the retardation, the deceleration. Let me put it, note. The deceleration. If that asks for that. Deceleration would have been equal to not rise over run, but fall. Be equal to fall over run. Because deceleration knows that the speed is falling. How fast is it falling? We're falling at the same 12 by the same 12 over 8. So it would have been a positive 1.5 meters per second squared. If they had asked for the deceleration, I'll put this in red. They didn't ask for this, but they do that sometime. Instead of asking for acceleration in the third phase, they could have asked for deceleration. So I'm putting that as a little note for us to be mindful of that. Okay, I might do another question, and instead of asking for acceleration in the third stage, where the speed is falling, they could have asked for deceleration or retardation. So instead of deceleration, it could have also been retardation. Same thing, retardation. So in that case, you wouldn't put the negative on it, guys. It's very important. You would not put the negative on it. All right? Very important. Because deceleration already means that the speed is falling. The question is, how fast is the speed falling? It is falling at 1.5 meters per second. That's why I have the per second squared here, because meters per second per second. All right, that is not number done. Next question. Let's look a bit smaller. So if that asks for this, that's what you'd have to put. All right, 1.5. All right, next question. That question done. Number 9, sorry. Used to be number 10. So the circle shown below has a center O and the points A, B, C, and D lying on the circumference. A straight line passes through points A and B. Angle CBD is 49 degrees, that's right here. And angle AOB is 37 degrees right here. All right, let's look at this now. Write down the mathematical names for the lines BC and OA. This line BC is a chord. See there? Join 2 points on a circumference is a chord. This line OA is from center to the circumference as a radius. OA is a radius. 3 marks. Chord and radius, 2 free marks there. Next question says, Determine the value of each of the following angles. Show detailed working where necessary and give a reason to support your answer. First angle I want is angle X. Let's look at the diagram. Angle X is right here. This one is easy. Why? Because this is a radius. This is a radius. So this triangle is isosceles. Remember that triangle you have to always identify it. This is isosceles. Because the radius and the radius here are the same length. So it means then that this angle over here is also 37, right? Let's mark it. It makes it like a clearer. So this is an isosceles triangle here that I'm marking out because of the two radii. And once you know one angle in an isosceles triangle, you're blessed because you can find the other two. Because this angle over here is also 37. Because of the isosceles triangle, this is 37 right here. And then the one at the center there that you want is 180 minus the sum of these two. So the calculation is going to be that the x is going to be 180 minus 2 times 37. If you notice, I'm not putting on the degree because the question gave us the angle as x degrees. So the x is just a value. You don't need to put the degree on it. So you work this out, that is the value of x. What is your work out to? 106. Let me copy this down and tell the examiners that ISOC is strong, right? Let's put it down here. And the reason is that total angle in the ISOC triangle is 180 degrees, right? That's the reason. Total angle in the isosceles triangle is 180 degrees. By saying it is isosceles, that will explain why I did 2 times 37. All right, next one. I want y. Let's look at the diagram again. So we now know that that angle, we now know this angle right here. Now we want angle y. What is now? So this triangle now is a right angle triangle, you know, this one over here. Why is the right angle triangle? Because it is subtended by a diameter. It's angled in the semicircle here. So this angle up here, subtended by this diameter, is 90 degrees right here. And so these two angles are complementary, meaning that they add up to 90 degrees, those two. All right? The two angles other than the 90 in a right angle triangle are complementary. They add up to 90 degrees. So it means that this angle here that I want is 90 degrees minus 49 degrees, which is how much? 41 degrees. So the y equals 41. So if first tell him that this angle is 90, now we can put it here on the diagram and leave it. You can say that this angle is 90 degrees. But why? Because it's the angle subtended by the diameter. Angle subtended by a diameter is always 90 degrees. And then now, these two angles add up to 180, add up to 90, sorry, because they are in the right angle triangle. Total angle in there is 180, right? And you have this one as 90 already. All right, so angle BCD is 90 degrees first. All right, so I'm gonna just leave it there. It's on the chart. So down here, the angle is 41. It becomes 90 minus 49, which is 41. Wanna say the angle, where is it again? BCD is 90 degrees. Angle BCD equal 90 degrees because it is subtended by the diameter. And then this calculation up here now is because total angle in triangle is 180. Total angle in the triangle is 180 degrees. That's the next thing that we use. That's how we did that. All right, done. That is it. All right, moving right along. Bearings question. This question said, diagram below not drawn to scale shows the route of a ship cruising from P to Q, and then to R. We don't care about the name of the cities, just P, Q, and R. The bearing of P from Q is 133 degrees, and I show it on the diagram for us. Beautiful, they show it for us on the diagram. And the angle PQR inside here is 56 degrees. It shows that as well. And also gave us these two distances that they didn't mention, but they gave us. So already we can work in this triangle and use cosine rule to find this side. You know, already we can do that. Because we already have two sides and an angle between. So we can find cosine rule, use cosine rule to find that side over there. Which I'm sure they're going to ask for that. Question said, calculate the angle W. That's this angle right here. What is angle W? So what we have to do to calculate angle W, what we can do to calculate angle W, we can do this. We can make a big Z. Look, we can make a big Z like so. Watch this. Come down this side parallel, those two sides parallel, and then join them with this line here. And so the angle in this Z over here equal angle in this Z over here. So that, so the total angle here says 133 degrees. So the W is 133 minus 56. But I can say that. So the W is going to be 133 minus 56. That's not the only way, you know, but that's a good enough way. The W is 133 minus 56. What I work out to? How much? 77. I'm not going to put the degree on it. But the question said, what the W is 77. So the angle is 77 degrees. So the W is 77. So the angle is 77 degrees. So we can say W degrees is 77 degrees. That's it. All right. So that's what I use. I use Z angles, right? Z angles to get the W. Another way you could have done it though, another way you could have done it is to calculate this angle in here and use co-interior angles instead. All right, and so the angle inside here and the angle inside here are up to 180. So this angle would have been 180 minus the 33, which is what? 47 degrees. And then total angle on straight line is 180. So that, to do that as well. But let's do the mathematics the easy way. All right, so that is 133 degrees. I just showed it a while ago. Next part says the distance PQ. That's the distance PQ over here. I'm going to use cosine rule. Let's do it right up here and then copy it down. So cosine rule for PQ. So cosine rule. So it's going to be start like Pythagoras theorem, not PQ. It's P to the amount of PR. It's PR itself, PQ. Let me see. Oh, I want a bearing first. The bearing of P from Q. Oh, my bad. I want a bearing first. The bearing of P from Q. So going from Q to P. Let's mark that diagram, mark that angle in the diagram. So going from here to here, the bearing. So the angle that I want, let's draw it out in purple so we can see it. So on this north line, I'm going from Q up to P. So I don't want this clockwise angle here now. All of this angle all the way around here, I want. That's the angle that I want. So it's kind of easy, right? Because if you divide it like so, the vertical line. It will be 180 degrees over here, plus 33, plus the W. Let me take out this 133. Put the W. What was the W again? The W was 77, right? So inside this is 77. Right here. Good. So it will be 180 up to here, plus 77, plus 56. That's going to give us the angle that we want. But I say that purple angle, 180 plus 77 plus 56. So that bearing angle that I want, which I have as purple on this diagram, the 180 degrees straight line, plus the 77 inside here, plus the 77, plus the 56. That's not the only way. What's the record to? 300 how much? 313. Another way could be because this angle is 47 inside here, right? Don't it? Or the co-interior angle, this angle become 47. We could have instead done 360 minus 47. I've done it that way as well. To get the bearing angle, right? But I've got the same 313 degrees. So you have two ways you can do it. All right, in the case, that's the answer, 313. All right, let's use the method where we added up everything. So when I say that the bearing is theta, and that theta becomes 180 degrees plus the 77 plus the 56. Add them up. And the answer is 313 degrees. Let's put the R. Or the theta is 360 minus the 47 degrees in there, which is 313 degrees. And let's put out get the 47 up here from now. Let's put out get the 47. So it's 47 degrees in here. This angle would be 180 minus 133. All right, 180 minus 133. All right, to get that 47. So we could have done 360 minus 47, get the same answer. All right, so that is that bearing. Next angle, next thing they want is the distance. Want anything after that? No question done after that. So the distance they want. So let's copy it. Let's do it up here now. Cosine rule. And then copy it down. So Pythagoras theorem working in this triangle, the angle in there is 56. So then it becomes that PR is the square root. Start like Pythagoras theorem. This side squared plus this side squared. 290 squared plus 210 squared. Then subtract a piece. Minus 2 times the 290 times the 210 times the cosine of the 56 between them. That is the cosine rule. Let's move it down. Let's move it down. So those are the values. I need to put them in here now and work it out with the calculator. That is it, right here. And let's work it out with the calculator now. What can I get? All right, so I'm going to give it the 3 figures. 245, 245, 245 kilometers. All right, I trust that you are correct. Anybody else online got 245? Anybody online got 245?
Yes, sir, I got 245.
All right, cool. All right. That question done. Last question. Finishing early to them. Last question. They give us that matrix with 2 unknown values. And they tell us that it's a transformation that maps R onto R prime on this diagram. So this R is mapped onto this R prime up there. So what kind of transformation is it? It looks like a rotation to me this way. All right, and I know that one of my rotation matrices set up like that, anti-clockwise rotation matrix. It could be you know your matrices, you know. Just gonna check and confirm it. All right, so it maps this point onto this point. So we can check the values, right? So let's write down the points first. So the point R is 2, -5. We're gonna use them. And R prime is 5, 2 up here, 5, 2. And this is mapped onto this using the matrix M. Now, how does that work? It means that the matrix M times the point R equals R prime. So we can set up an equality of matrices to do this. The M is 0P Q0. We multiply that by the R matrix, which is 2, -5. We are getting the R prime matrix, which is 5, 2. So we have an equality of matrices situation here. Let's make this a little smaller and zoom up. So what we can do, we can proceed and say, okay, this 5 over here is this row times this column, and set up an equation. All right, so it would be that the 0 times the 2, which is 0, and the P times the -5, which is -5P, is equal to this 5 over here. So divide by the -5, we see that the P equals -1. And so we have the P already. And then we can see that this 2 under here is a product of this row and this column. So we can set up another equation here that says the Q times the 2, which is 2Q, and then the 0 times the -5, which is 0, is equal to this 2 over here. So if this 0 is immaterial, so divide by this 2, you get that the Q equals 1, which is what I suspected in the matrices. So the matrix then, that's the P and the Q. You know, these are answers, you know. That's an answer right there. That's an answer right there. Based on what the question wanted. The question wanted the value of P and Q. But I'm also going to make a determination of the matrix. And let's make a note of it. All right. So the matrix then, M, is 0, -1, 1, 0. That's an anti-clockwise 90-degree rotation about the origin matrix. It's good when you know the matrices. And do they ask us for it? Yes. Describe it. It's an anti-clockwise 90-degree rotation about the origin. Remember, anti-clockwise rotation is positive. So you could have said a positive 90-degree rotation about the origin. Anti-clockwise rotation is positive. Clockwise rotation is negative. I've been saying it every week, or you like it the first year. I've been saying the same thing every time I get the chance. Anti-clockwise rotation is positive. Clockwise rotation is negative. Why am I saying it all the time? Because I see it on past paper already. I've seen it on papers before, where instead of saying clockwise 90 degrees, they say negative 90 degrees rotation. Instead of saying anti-clockwise 90 degrees, they say positive 90 degrees rotation. So I'm telling you, anti-clockwise rotation this way is positive rotation. Rotation this way is negative rotation. All right? I'm telling you. So we get a question from the people with that, you know, and I don't get it right, you know, I can't blame me, I'm telling you 1 million times already. You're not going to see it in a lot of past papers. But it comes on past paper already, especially on multiple choice. I'm telling you. All right. So if you come on a paper 2, if you come on a multiple choice, it can come on a paper 2. All right. So let's go. So this is an anti-clockwise rotation. So it's an anti-clockwise 90-degree rotation about the origin. Remember, instead of saying anti-clockwise, you could have said a positive 90 degrees rotation. Because anti-clockwise rotation is positive. So we could have said a positive 90-degree rotation about the origin. Positive. Positive rotation is anti-clockwise rotation. All right, so we'll give the name of the rotation of the transformation, rotation. We'll give the three components of rotation: angle, direction, and center. Let's do it all three when you're describing it. See, it's 3 marks for it. One for each one that you say. So leave off that it's about the origin, you lose a mark. You have to state the center of the rotation. All right, next question. Part B. Hold on, is the last question we reach? Oh, we're done. Next question says PQRS is a parallelogram in which PQ is V, PQ is U, sorry, right here. That's this vector is U. And PS is V right here. Like these questions, parallelogram questions. Because the parallelogram, if this vector is V across here, then this vector appears also V in the same direction. So I'm going to put that on from now. Now the vector from Q to R is also the vector V. Just like this one, V. And since these two sides are equal and parallel, since this vector over here is U going up, then this vector going up is also U. So I'm going to put it over here as well. The vector up here going up is U. So I have those two additional vectors on the diagram. Remember, we don't yet know this vector across here, but I'm sure it's a combination of these two. It tells us that that M is on QS, such that QM to MS is 1 to 2. So QM is one part, see, one part. QM is one part of the line. I'll put like a 1 on there. MS is 2 parts of the line. MS is 2 parts on the line. Means that the total length of the line in terms of the ratio is 3. And so this piece of it, for example, is 2/3 of the whole line. And this piece right here is 1/3 of the whole line. The whole line is QS. So we can express the vectors in those proportions, right? Those fractions. Question says, write in terms of U and V, means that U and V must be in the answer, an expression for the vector QS. In other words, going from Q to S. We have to initially go along the vector directions that we know, which is this one and this one. So we can say, okay, going from Q to S, based on this diagram, can come out to R first using the V, and then go down from R to S. We have to use minus U, while we're going in the opposite direction to the U, so it's minus U. So it's V and minus U takes you from Q to S. Simple as that. So we can write out like this too. It is Q to R first, and then R to S. The Q to R is V, and the R to S is minus U, right here, minus U. Why is it minus? Because we're going in the opposite direction to the U. The U is going up this way. So from R to S, you're going in the opposite direction to U, so it's a minus U. So that is QS. So it's now like we know the vector now. We now know the vector across here. It is this. We now know the vector QS. We now know it. So we can travel on that route now using this vector QS. We now know what that vector is across there. No longer are we blind to that vector. We now can travel along the vector here and parts of it. Question wants us to tell them QM, at this piece, it is just 1/3 of the whole thing. 1/3. So the QS is simply 1/3 of the whole QS. So then 1/3 of that QS right there, 1/3 of it. So then 1/3 of each part. And so it's 1/3 of the V minus 1/3 of the U. That becomes your vector QM. QM. Next part says, we must show that MR is equal to that. To show that MR is equal to this, we need to just calculate MR. Let's calculate MR. So let's look at the diagram over from M to R. Let's calculate MR. So say M here, I'm trying to go to R. So easy. We're going to go down the same direction as the QS. We're not going to go backwards. If we go backwards, we have to introduce a negative, and sometimes can get mixed up with the negative, right? So they're going to go down to S first, and then go from S up to R. That's how we're going to go from M to R. So we can write it right here. To go from M to R, we're going to go from M to S first, and then go S to R. It's just that the M to S is 2/3 of the M of the QS. M to S is 2/3 of the QS. So let me copy this down now. I'll cut and paste it down here so now. So remember, you know, we're trying to prove this. We're trying to prove this thing by working it out. So the MS, as I said, is 2/3 of the QS. 2/3 of the QS. That's what the MS is right here. And then we're adding back the SR. And the SR is just U on the diagram. Remember, the QS was V minus U, you know. Don't forget. So we're now doing 2/3 of this thing, right? So this then becomes 2/3 of the V minus 2/3 of the U. That's what this is. And then we're adding a SR, which is a U. So we're adding a U. Because the SR, remember, is U up here. See there? The S to R is this U. All right. So now we have the thing. It's a matter of showing that this will factorize out to that. All right. So let's make this a little bit smaller on the screen. Zoom up and work it out. All right. So now we want to this is the only V term there. But the answer has a U value first. So let's work out what the U values are. This is a whole U minus 2/3 U. A whole U minus 2/3 U, we're going to leave it with 1/3 U. A whole minus 2/3 is 1/3. So this is 1/3 U. That's the only V term there. So I'm going to get plus 2/3 V. And all I've done in this is to factor away the 1/3. So factor away 1/3 from these two expressions. Out of this, we're going to be left with the U. Out of this, if you factor away the third out here, we're going to be left with the 2V, which has been shown. That's what they wanted us to show right here. That is it, same thing. All right, that's what they wanted. So that has been shown. We'll come to down here now. It says T is the midpoint of PQ. Must prove that R, M, and T are collinear, meaning that they are on a straight line. R, M, and T. T is the midpoint of PQ. Let's go and adjust it on the diagram now. So T is the midpoint of this line right here. What I'm going to do, I'm going to implant it, the T on the diagram, right inside here at the midpoint right here. I'm going to call this T. Let's change that U to a T. So that T divides the line half and half. Shall put this in a different color, so we see that it was not originally there. And put it in blue. Good. And then now I'm going to put on these vectors now. Remember, the whole vector was U. And this divides it half and half. So it means that this vector is half of U. From the P to the T is half of the U. And from the T to the Q is another half of the U. I want to show that these 3 points now are collinear. Let me show them, draw them in purple. These 3 points. Show that they're on a straight line. You can see it on this diagram as well. So to prove collinearity, remember, you need 2 vectors between the 3 points. And you have to show that one is a merge with the next, and there is a common point. In other words, In other words, I have to show that you have parallel vectors, the common point between the 3 points. All right. So we want to see which vectors, which 2 vectors from these 3 points we can use. Do we have any as yet? Yes, we just calculated MR a while ago. MR, we already have MR to use. But we're not going to use this MR right now. We're going to use this one with the values separate. All right. So I'm going to use that MR right there. We're using MR to prove it, which is a third U plus 2/3 V. And which other vector can we use? Remember, we already used the MR. So now is either going to use the RT vector or the MT vector. We already use a vector connecting these two. So it's either going to use a vector connecting the R and the T, or we're going to use a vector connecting the M and the T. Let's look at the diagram and see which one is easier to find. So we can use the M to the R, the T to the R, sorry, or we can use the T to the M. But it's obvious that the T to the R is easier because I know this vector is half U. I know this vector is V. If you were going to use TM right here, they'd have to come here with the half U and then use a QM, where the QM we worked out was this vector. So you have to do some calculation to use the other one, which is the Q to R, the T to R, sorry. You don't need no calculation because you can see that this is half U plus V. You can see it on the diagram. Look go from T to R. This is a half U right here, and that's a plus V. So it's half U plus V. TR is half U plus V. So let's go and write that. TR is half U plus V. So we're going to write that. TR is half of U plus V. So we now need to show that these 2 vectors are parallel, and we're going to see that R is going to be our common point. We have to show that 1 is a multiple of next. When you have vectors like this, what you want to do is get rid of the fractions first, because the fractions make it more difficult to see the relationship between the vectors. So what I'm going to do is multiply this one by 3 to get rid of the fractions. The lowest common multiple of the denominator is 3. Multiply this one by 3 first. Now multiply 2 by 3, multiply this first by the 3. I get 3MR equals, multiply this by the 3, I get U. Multiply this by the 3, I get 2V. So I get plus 2V. And to get rid of the half, the fraction out of this one, I need to multiply 2 by 2. I don't want any fraction because the fractions make it more difficult to see the relationship between the vectors. And so I'm going to multiply this second vector by 2. When I multiply by 2, multiply this first by 2, I get 2TR equals, multiply this by 2, I get just U, plus multiply this by 2, I get 2V. I know I'm at the state where I can equate, because this and this is the same vector expression. It means that this vector is equal to this vector. Those are equal. And so we're going to equate the vectors. All right. So we can equate and then write that 1 is a multiple of the next. So we're going to equate them. And when we equate them, we're going to get that this 3MR is equal to this 2TR. This now means 2 things. 2 things that mean here, which you must state. First, I'm underlining a common point. And I write the 2 conditions that are presented here that is resulting in the points being collinear. First thing is that because 1 is a multiple of the next, the 2 vectors are parallel. Let me shift this over a little bit so I can write out everything. So it means that MR is parallel to TR. That's the first thing that must happen for you to have collinear points. You want parallel vectors. And then R is on both vectors that are parallel. So you say R is a common point, which is the second thing that you need to happen to have collinear points. R is a common point. You have to write out all this on the exam paper to prove collinearity. So because you have these two conditions that mean, we can draw the conclusion and say, therefore, the points involved, which are M, R, and T, I can write it as this, R, T, and M. R, M, and T. R, M, and T are indeed collinear. And that is paper done in record time. Record the time, done. All right, check up and let me hear some grades now. No? Always stay online. Nobody don't check.
Okay, I'm still
let me hear
checking.
some grades. All right, good. Check up and let me hear what's happening here. And then it's stable this morning. Hope it'll be stable again later this evening. Let me hear your grades, guys. Let me hear your grades. Remember, the target is 85%, 85 out of 100. Next week the target is 95, you know.
90.
Huh?
Sir, I get 86.
86?
Yes, sir.
Who is that? Alexander?
Yes, sir.
Very good. I have a timetable now. I thought we were coming today. I have a timetable.
Yes.
I get it Wednesday. Hey, brothers. Very good, very good. So next week you have to get 95, my boss. So you pass the target today, which is good. 85 is the target. You reach 86. Come on, let me hear some more grades now.
Yeah, about 82, sir.
82, Dejan, you're just below, man. You're just below. All right, we'll accept that. But you have to go and redo the question. You to Alexander, the questions that you got wrong, you have to go and do them over. Make sure you understand why you got them wrong. Right? And clear the mistake, clear the misunderstanding. Whatever it is that caused you to get them wrong, you have to see what it is, work it out. If you don't know, you let me know. I'm going to share the video after the class so you can go back and look at it if necessary. But make sure you understand why you get them wrong, so you don't make that mistake again. How much you get? Wow. 87. Yeah, man, you're not going to learn from the mistake on the paper here. And look here. Hey, listen good now. Everybody listen. So next week, Saturday, you're doing the 2 papers on the same day. So this is where we're going to go next week, Saturday. Listen. You're going to do 1 paper first, right? At 9 a.m. I give you 2 hours and 40 minutes to do it. When you're done, I'm going to give you the answers. Good? After I give you the answers, you're going to let me know which questions you want me to explain. We're going to do that for about an hour or so. I'm not going to work the entire paper. Only the questions that you want me to explain. I'm giving you the solutions. After I give you the solution, you look through the paper and say, sir, looking at the solution, I still don't understand this. And I'll work it out and explain. You get me? Then when we finish that exercise, you're going to do a second paper. So you're basically getting 2 chances to get 95. You're getting 2 chances to get 95 next week. So do the first one at 9 a.m. End at 11:40. I give you the answers and the solutions. And maybe by say 12:30 or so, we come back and you say, sir, explain this one. You look through the solutions, mark yourself, so you make your mistakes and so on. And say, sir, explain this one, explain that one, whatever. I go through the questions that you want me to go through, everybody. And then I give you the second paper to do. Another 2 hours and 40 minutes again. Second paper, same day. All right? You work it through and the same thing. When you finish, I give you the solutions for it. Because we're clearing those 2 papers from Saturday. And when I come back on the Sunday for those 2 papers, we're clearing them from Saturday. So I'm going to go through the questions that you want me to explain. Not all of the questions, only the ones that you want me to explain. Because I'm certain that a good number of the questions you want me to explain. Only the ones that you want me to explain. I'll go through those questions. And then you go home. And then now, when you come back Sunday coming back at 11 a.m., working only up till about 4. Sunday now is when you're going to come and you bring back all the questions that you want me to do one last time. That's Sunday. So any question from that you have gone through before that are in the past papers that we have done, because we have exhausted 24 past papers now. So from all those 24 past papers that we have gone through, you're going to tell me which questions you want me to go through again and so on. And explain again. That's Sunday. So you telling me which question to the Sunday. We'll do that and we'll do that and we'll do that. And then maybe about half an hour before you leave, I'll tell you what you do, how you operate on the exam day. You have to follow everything that I tell you to the T. How you operate on the exam day. Like, for example, you go home and sleep and not study nothing else next week Sunday. Studying done when you leave here next week Sunday, 4 o'clock. No more studying at all. Till the exam, 9 a.m. Monday. No more studying needed. No need to do nothing else. You need to just relax your brain and rest your brain after we finish. Anything you don't have already, trust me, forget it. You can't tire out your brain. If you go in the exam room tired, the tiredness alone can cost your marks because you can't think clearly. You need to be able to think clearly. You need to be fresh, fully rested at 9 a.m. Monday morning. So I don't want anybody to study anything at all after you leave here 4 o'clock. If you don't beg me, I might say, okay, we can do something up until 6 o'clock. But from 6 o'clock, that's it, cut off. Nothing past 6 o'clock. Go on to bed, go sleep, watch a movie, relax, something. Relax in the brain. When I get up the morning of the exam, same thing. No studying at all, nothing. No look for nothing at all. When you come in here on a Saturday morning to do mock exam, you look for nothing Saturday morning. And just come, don't it? The same thing. Just go to the exam room. Just like you come here Saturday morning, you look for nothing before you come here. You just come, right? And do the paper, right? So the same thing on exam day. Just get up in the morning, eat, freshen up yourself, get yourself ready. I'll tell you the things that you have to get ready. Make sure you have available with you. And you go to the exam room. You look for nothing. In addition to that, do not allow, don't make nobody ask them for report nothing. On the day. Before the exam, you're going to see a lot of persons coming and say, oh, you do this again. Oh, you do that again. No. If they want to know how it is done, they ask you the week here. Last week, this for them asking. They can't ask you that on the exam day. The exam day, you are to do 10 questions only that day. Which 10 questions? The 10 questions on the exam paper. Those are the only 10 questions you're using your brain for that day. The 10 questions that are on the exam paper. You're not working out no other question that day. Everything in your head, it will come out. Believe me, it will come out when it is time to come out. Don't worry yourself. Don't study nothing. Just rest on the brain, go into the exam room, fully rested. If nobody comes and says, show me how to do this. No. Should ask me that last week. So if you don't have no friends there, you can't tell no week here. Tell them, send a message to them. Anything you don't want to explain on the morning of the exam, ask me from no, because I'm not going to be explaining anything on the morning of the exam. So tell your friends them, but Virgin, dog, if you want me explain anything to your dog, ask if I know. Me not explain nothing for exam morning. You want me explain something to your dog? Ask me no. And that you say to your friend them and your Virgin them. The dog gonna call one of that dog. You know. See? You say, you want me explain nothing? Tell me if I know if you want me explain nothing, because I say, man, exam, you can't ask me nothing, I want if I know. Don't come exam morning, come ask me nothing. I'm not telling nothing exam morning. Anything you want to know, ask me no. So all the bridging them, you know, you're going to say exam morning. You know, so them going to ask you something. Tell them from tomorrow when you see them at school. Or if you call them or WhatsApp them, say, you know what, I explain nothing. I'll put on the WhatsApp status. All my friends who want me to explain anything to them in the maths, ask me from now. I will not be explaining anything to anybody on May 13th, the day of the exam. Do not ask me to explain anything to anybody on May 13th. I will be in rest mode. I'll be resting my brain before the exam. We're not looking at anything. You're going at the exam, brain fully rested. And all you will need before you go in the exam room, 1 little teaspoon of honey. Calm yourself down. Honey. Serious. Honey. So if you feel like you're a bit nervous before you go in there, 1 little teaspoon, calm yourself down and go in there. And deal with it. You are well prepared and have none to worry about. You are well prepared. The average person out there knows nothing 2 mock exam much as 24. The average person not even do 2 mock exams. Under the whole of 24 and work to the whole of them. You get me? By the way, we're doing another 2 on Wednesday, right? I know that, right? So I'm actually thinking, you know, the one on the Wednesday man and one on the Thursday. So I'm actually thinking if I should just do another assessment on Wednesday. Rather than do a paper, just do another assessment on Wednesday. Huh? I'll decide. I might do another assessment on Wednesday. All right, give another chance to do well on the assessment on Wednesday. So I decided that by Wednesday, if we're going to do another assessment, or because if I'm going to give you another paper, it's a whole time paper, long time paper. Because we have done all of the recent papers now. We don't have no more recent paper to do. We have done all of the recent paper. The syllabus that you're doing, we have done all those papers multiple times. So if I'm going to give you a brand new paper, it's going to be a old paper, like from about 2009 or something like that. Right? But the syllabus with level questions and all of that. So I prefer at this stage for us to just be working on papers that are aligned with the actual exam. So I think I'm going to maybe just do another assessment on Wednesday. All right? And see where we're at. All right, that is it. So come now, on terms of grades now. Deshaun, what's your grade? Gavri. On time, not tell me nothing yet. Gavri, do the paper. Gavri. Oh, Gavri. Hunter.
Yes, sir.
How much you get?
I'm still calculating. Like 78%.
Oh, you're far short. All right.
Yes, sir.
All right. So go and so you have to make it up in a 95. I forget next week, 95. So everything that you got wrong, you need to go and redo them, right? And make sure you understand why you get them wrong. Don't get them wrong again next week. I think I'm gonna do our assessment Wednesday again. Give you another chance to get 85% on Wednesday. All right, and then we're going for the 95% next week. Dijon, what you got? About Dijon about this paper? Dijon did the other paper. Bedward did the paper that we're doing tomorrow. Anyway, guys, that is it. What time is it now? 2 o'clock. So at 4 o'clock, give me a send no woman, I'm gonna join online. I don't want to go home. And I can go home and still join online at 4 o'clock. Huh? Yeah, I can go home, I'm gonna just do an online session at 4 o'clock. And work through the topics that we say we're gonna do. Rather than stay here. Go more relaxed. That's Sunday. At 4 o'clock, I'm gonna join online. Alright? Alright? Before I leave, do I want you much to get to everybody? Alright, guys, I'm gonna end the session now. Bye online, I'm gonna hang up now.
Yes, sir.